Stars are not eternal, they have lifespans just like us, but a star's death is far from quiet. It's a grand event, a cosmic spectacle. Imagine the most dazzling fireworks display, then multiply that by 1,000,000,000. How a star dies depends on its size. Smaller stars like our sun gently shed their outer layers. Larger stars meet a more dramatic end. They explode as supernovae, becoming the brightest objects in the universe. Stars, like dreams, begin in the darkness, in vast, cold clouds of gas and dust scattered throughout galaxies. We call these clouds nebulae, the cosmic cradles where stars are born. The ingredients? Mostly hydrogen and helium. Stars are baked by gravity. Gravity pulls these ingredients together. Eventually, nuclear fusion ignites. This is the moment a star is born. This energy is what makes the star shine. Once a star ignites nuclear fusion, it enters what astronomers call the main sequence. This is the star's adulthood, a long, stable period where it shines brightly, fusing hydrogen into helium in its core. Think of it like a campfire. You add logs, hydrogen, to the fire and they burn, releasing heat and light, energy. A star does something similar. It fuses hydrogen atoms in its core, releasing the energy that makes it shine. Our sun is a main sequence star about halfway through its 10 billion year lifespan. It's been steadily burning for about 4.6 billion years, providing the light and warmth that sustain life on Earth. But the main sequence isn't forever. Eventually, like a campfire running out of wood, a star will run out of hydrogen fuel in its core. When this happens, the star enters a new phase in its life, one that's much more dramatic and consequential. Imagine a car sputtering when it's low on fuel. That's what happens when a star like our sun runs out of hydrogen. The outward pressure from nuclear fusion weakens, and gravity starts to win. The core contracts and heats up, while the star's outer layers expand dramatically, turning it into a red giant. In about 5 billion years, our sun will swell up and engulf Mercury, Venus, and Earth. Imagine our planet consumed by the expanding sun. The core gets so hot it can fuse helium into heavier elements like carbon and oxygen. This releases more energy, making the star more luminous. The red giant phase is a time of great change and instability for a star. Section 5. The gentle death of a sun-like star. For stars like our sun, the red giant phase doesn't last forever. As the star runs out of helium, its outer layers are ejected, forming a glowing cloud of gas and dust. This cloud is called a planetary nebula. At the center, the star's core remains as a white dwarf. It's incredibly faint, slowly cooling over billions of years. The ejected material is rich in heavy elements, crucial for forming planets and life. Section 6. Supernovae, the universe's biggest fireworks. While stars like our sun go out with a whimper, massive stars end their lives with a bang, a supernova. This is one of the most violent and energetic events in the universe, briefly outshining an entire galaxy. Imagine a firecracker exploding, but instead of a fleeting burst of light and sound, it's a blinding flash that can be seen across the cosmos. That's the power of a supernova. These stellar explosions occur when a massive star runs out of fuel in its core. Without the outward pressure from nuclear fusion, the core collapses in on itself in a matter of seconds, triggering a shockwave that rips the star apart. The energy released in a supernova is mind-boggling. In just a few weeks, a single supernova can outshine billions of stars combined. It's a cosmic spectacle that leaves behind a rapidly expanding cloud of debris called a supernova remnant. Supernovae are essential for the evolution of the universe. They forge heavy elements like gold and uranium, which are scattered into space, enriching the interstellar medium and seeding the formation of future stars and planets. Section 7. Stellar remnants, neutron stars, and black holes. After a supernova explosion, the core of the massive star is left behind. This remnant can take one of two forms, depending on the star's original mass. If the core is about 1.4 to 3 times the mass of our sun, it becomes a neutron star. Imagine squeezing all the mass of the sun into a sphere the size of a city. That's how incredibly dense a neutron star is. These exotic objects are like giant atomic nuclei, held together by immense gravity. They spin rapidly, emitting beams of radiation from their poles. If these beams happen to sweep across Earth, we detect them as pulsars. If the core is more than 3 times the mass of the sun, gravity wins the ultimate battle. The core continues to collapse indefinitely, forming a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. Black holes are some of the most enigmatic objects in the universe, challenging our understanding of physics and gravity. They are invisible to telescopes, but their presence can be inferred by their gravitational effects on nearby stars and gas. Section 8. Cosmic Recycling Planetary Nebulae. As we've seen, stars are not eternal, they have lifespans, and their deaths, while marking an end, also signify a new beginning. The material ejected during a star's death, whether it's a gentle outflow in a planetary nebula or a violent explosion in a supernova, doesn't just disappear, it becomes part of the interstellar medium, the vast expanse of gas and dust that fills the space between stars. This material is enriched with heavy elements forged in the star's core during its lifetime and death. It's like scattering fertilizer on a field, providing the necessary ingredients for new life to blossom. Over millions of years, gravity draws this enriched material together, forming new stellar nurseries, where the cycle of stellar life and death begins anew. The atoms that make up our bodies, the air we breathe, and the earth beneath our feet were all once part of stars that lived and died long ago. Section 9. Fading Away, the White Dwarf's Fate. While neutron stars and black holes are the remnants of massive stars, white dwarfs are the final stage of evolution for stars like our Sun. These stellar embers are incredibly dense, about the size of Earth but with a mass comparable to the Sun. Imagine squeezing all the books in a library into a grain of sand. That's the kind of density we're talking about with a white dwarf. Despite their small size, white dwarfs are incredibly hot, glowing with the leftover heat from their former lives. But over billions of years they slowly cool down, radiating their energy into space. Think of a hot coal taken out of a fire. It gradually loses its heat until it eventually becomes cold and dark. As white dwarfs cool down, they fade from view, eventually becoming black dwarfs. These are theoretical objects, as the universe is not old enough for any white dwarf to have cooled down completely. It's a slow, drawn-out process taking trillions of years, far longer than the current age of the universe. Section 10. From Death-Life, the Cosmic Impact. The death of a star, whether it's a gentle fade-out or a spectacular explosion, is not the end. It's a transformation, a recycling of cosmic material that paves the way for new beginnings. The heavy elements forged in the hearts of stars, scattered into space during their deaths, become the building blocks of planets, moons, and even life itself. Think of it like this. The calcium in our bones, the iron in our blood, the carbon in our DNA, all these elements were once created in the nuclear furnaces of stars. We are literally made of star stuff, connected to the cosmos through this incredible cycle of life and death. The death of stars also shapes the structure of galaxies. Supernova explosions, for example, can trigger the formation of new stars by compressing nearby clouds of gas and dust. They also enrich the interstellar medium with heavy elements, influencing the evolution of future generations of stars and planets. Section 11. A cycle of life and death among the stars. The next time you look up at the night sky, remember that you are witnessing a cosmic ballet, a dance of life and death playing out on a grand scale. Stars are born, they live, and they die, but their deaths are not the end. They are just one chapter in an ongoing story, a cosmic cycle that has been repeating for billions of years. From the ashes of dead stars, new stars are born, continuing the cycle of creation and destruction. It's a reminder that even in the vastness of space, nothing is truly lost. Everything is transformed, recycled, and given new life. So, as you gaze upon the stars, marvel at their beauty, but also remember their stories. They are tales of cosmic fire and fury, of creation and destruction, of life and death, all intertwined in a breathtaking tapestry that stretches across the universe. We are all part of this cosmic story, connected to the stars by an unbreakable bond of stardust and energy.